Okay, finally now, welcome to this next video, which is on negative indices and scientific notation. So our learning goal for this one is that you will be able to apply the index laws to numbers and express numbers in scientific notation. And this you'll be able to express a number in scientific notation, which is something you'll learn about very soon. You'll be able to interpret numbers that are already given in scientific notation, and you'll be able to understand and apply numbers when there are negative indices. Okay, so the number of zeros in these numbers is too damn high. Now, in science, a lot of the times we need to deal with humongous numbers and teeny weeny ones. And so whenever that's happening, there are sometimes a lot of zeros that we need to deal with. So for example, an X-ray, so if you go to a specialist, get an X-ray, it's a little photon of light that sort of wiggles and waves and looks like this. And this measurement here, this here is called the wavelength, and it's known by this letter lambda. Okay, this is our X-ray flying along through space, and this distance here is only about 0.00000000005 meters. Okay, so that's really, really small. And if you're going to write that, it is so annoying to have to write out all those zeros. So what we do instead is that we have this way of writing called scientific notation, which is, we write that instead as 5 times 10 to the power of negative 12 meters. Okay, and that just makes life so much easier for us. Okay, we also need to deal with other humongous numbers. So for example, if you had in your hands, so a little box of carbon 12, okay, and you had 12 grams of it, you would have 6.02 times 10 to the 23 atoms of carbon. Okay, so we need to deal with sometimes ridiculously big numbers like that 6.021 and teeny weeny ones like the wavelength of an X-ray. Okay, so we're going to move on now and have a look at some of these things. So some key ideas. First, we're going to look at the negative indices. So a number that is with a negative index is the reciprocal of the same number with a positive index. So remember, reciprocal was an idea that if we had a number that was x, the reciprocal of that would be 1 over x. Okay, remember that's what the reciprocal meant from fractions and things. Okay, so for example, if we have here a to the power of negative x here, a to the power of negative x here, and that's equal to 1 over a to the power of x. Okay, so for example, if we have a to the power of 3 over a to the power of 7, you'll know now that you can rewrite that as, keep losing my cursor, a to the power of 3 minus 7, which gets us a to the power of negative 4, which is 1 over a to the 4. Okay, and that's how we go about using our negative indices and things. I might get myself a bigger pen here, I think. There we go, that's a little easier to see. Okay, so scientific notation, however, is used to easily express particularly large or small numbers that would otherwise be unwieldy for us to use. Scientific notation has a particular format to it. So I've got some number a times 10 to the power of m, okay, where a is 1 or greater, but has to be less than 10. And m is just some number that's an element of the integers. Okay, so this little thing here, that means element of, so it's inside that set, and the z that's written all special like that, that means the set of integers. Okay, all the integers that exist. Okay, so this one here, so a is this piece here, and we say this thing here at the front here, this is what we call the significant figures. Okay, significant figures, and then we got the m part here, 10 to the 22. For by the way, this distance here, this is the distance, this number, to Andromeda Galaxy. And so that's the one that's going to be colliding with us in a couple of million years' time or something. So, I don't know, look out for it. It'll probably be pretty bright. Okay, now large numbers, so ones that are really big, have positive powers of 10, and small numbers have their negative powers of 10. Sometimes you'll run into some common prefixes using meters. So we have here, we've got gigameters being capital GM, and that's times 10 to the 9. Megameters is times 10 to the 6. Kilometers is not a capital K. Oops. That is a little k. And that's times 10 to the 3. Millimeters, sorry, meters is just m. Centimeters, you don't see that necessarily a lot in science, sometimes for measuring and things. Millimeters, micrometers, nanometers, etc. Now obviously there's ones that are bigger, ones that are smaller, but they're the main ones that you'll see. Okay, let's simplify the following expressions as some worked examples using some positive indices. Okay, so the first one, m to the power of 3. So remember, we rewrite that as 1 over the number with a positive index. Okay, so that is 1 over m to the power of 3. This is 4p to the power of negative 2. Now this is an interesting one. Remember, we deal with our indices first. So we know it's only the p that gets that negative 2 index applied to. So we're going to have 4 over p to the power of 2. Okay? Alright. Similarly with this last one, this next one here, the negative 7 index only applies to the y. So the rest of it doesn't change at all, and it will stay on top of the fraction. So 5x squared over y to the power of 7. And lastly here, this was a bit of a tricky one. So let's rewrite it as we know. So we have already got 1 over something, okay, but that 1 over is z to the power of negative 5. So that's 1 over z to the power of 5. Now, when you see this kind of thing, what sort of happens is a bit of a trick, is the stuff that's down the bottom here just comes up the top of our fraction. Okay, it's a bit of a trick I'm happy for you to remember. So this will just end up as z to the power of 5. Okay, it's sort of it's 1 divided by 1 over z to the 5. And if you worked out the fractions using the tools that you already know how to divide using fractions, you would end up understanding why we get to our z to the power of 5. All right, let's do a couple of writing the value of some scientific numbers. So we have 4.35 times 10 to the 6. So the way that we do this is you write 4.35 and we're going to do times 10 to the power of 6. So we're moving our decimal point 6 places. So 1, 2, 3, 4, 5, 6. We fill up the rest of them with zeros, and that's our number. Okay, so we have 4, whoops, don't need a point, 4, 3, 5, 0, 0, 0, 0. Okay. There's our number. And this one here, 1.78 times 10 to the negative 3. Again, you write your number, the significant figures that are given you, 1.78. Whoops. And then we move our decimal point this time, because the negative value, we move it back the opposite direction. So we're going to go 1, 2, 3. This is where our decimal point will be. So we know there'll be a 0 here and 2 zeros there. So our new number will be 0.00178. Okay, always rewrite it. Don't just leave it there with all the arrows and stuff. It just looks messy. Okay, let's have a look at how we express these numbers now in scientific notation. So 5,800. So look at your number. So 5,800, and you look and you think, okay, so that a part at the start has to be greater or equal to 1 and less than 10. So we're going to have to put our decimal point here, in between the 5 and the 8. So how far have we had to move that? Well, 1, 2, 3 spots. So that means that we will have 5.8 times 10 to the 3. Okay. I usually had some units, so let's call that meters, and this would be meters. Okay, and again here. So let's rewrite our number again nice and big so we can see it. 0.00060034. And let's think about how far to move it. 1, 2, 3, 4, 5, 6. Whoops. That's a bit too many because our number is going to be here, because it'll be 6.034 will be our significant figures. So 6.034, how far we had to move to get there? 1, 2, 3, 4. So that'll be times 10 to the negative 4. Let's call this Henry's, and it'll be Henry's. Okay, so 6.034 times 10 to the negative 4 Henry's, which would be a really, really small inductor. Anyway, thank you so much for watching that. It was sort of a lot of information to deliver very quickly, and maybe some bit weird ideas in there somewhere, but it is a particularly easy sort of area to get hold of, but a very good one for you to sort out, because if you're moving into the scientific fields, you're going to deal with these sort of numbers all the time. Okay, but thank you so much for watching, and remember to come grab me or talk to me if you're having any issues with anything that's happened through this video. Thank you.